Okay, now we're going to talk about complex numbers. Okay, and how these complex numbers and what is the theory behind these complex numbers. Suppose A and B are two numbers which belongs to a set of natural numbers so that A is greater than B. Okay, then well, an equation of the form x plus A is equal to B, okay, is not solvable in natural numbers. Okay, say for example, what do you mean by this is suppose if A is equal to 3 and B is equal to 2, okay, then x plus 3 is equal to 2, okay, and it will give you x is equal to minus 1. Well, and it doesn't belong to the set of natural numbers. This x equals to minus 1 doesn't belong to set of natural numbers. So the set of natural numbers n is expanded to integers, okay, to include integers. Now the set of natural numbers is expanded to integers, okay. Now this is a problem again. So for example, if A and B are two integers, okay, such that xa is equal to b, now this equation is not solvable in integers, okay. xa is equal to b is not solvable in integers, okay. We started by having some problems in natural numbers, and then we said that okay, let's expand it to integers. Now there's a problem in integers also, because the equation like this, your xa is equal to b, okay, is not solvable in integers, okay. So say for example 3x is equal to 2, okay, so x would be equal to 2 by 3, okay. Now x equals to 2 by 3, 2 by 3 is not an integer, okay. 2 by 3 is not an integer, so there's a problem again. So integers themselves are expanded to include rational numbers, okay, that is to include q, okay. So now the set is going bigger and bigger. Now rational numbers are in the form of p by q, where q is not equal to 0. Then again there's a problem. So for example, x squared is equal to 7, x squared is equal to 5, x squared is equal to 4, x squared is equal to not 4, 3, x squared is equal to 2, okay. Now again, these equations, okay, are not solvable in q, okay. So there is no q which can actually solve these equations, okay. So there is no rational number which can solve x squared is equal to 7, okay. There's no rational number, okay. So there's a problem. So there is no rational number such that these equations could be satisfied, okay. So because this x square is equal to 2, okay, now here x has to become is somewhat what you mean as irrational numbers, okay. So q is expanded, that is your rational numbers are expanded to irrational numbers, okay. So rational numbers, they're expanded to irrational numbers, okay. And the set of these rational plus irrational numbers is your real numbers, okay. So rational plus irrational numbers are what you know as real numbers, okay. Real numbers, fine. Now the point is, we started by saying that you have a natural number, there's a problem, so you included integers. There's again a problem, you included what is your rational numbers. Then again there is a problem, you included what is known as your irrational numbers, and some of these rational and irrational numbers, they're forming up to what you know as real numbers. And these are denoted by this set script R. Okay. Now again there's a problem. Okay, there are certain set of equations which are not solvable in R. Okay, so for example, if you have an equation such as x square plus 2 is equal to 0, x square plus 5 is equal to 0. Okay, x square plus 3 is equal to 0, and so on. Okay, so these will give you x square is equal to minus 2, x square is equal to minus 5, x square is equal to minus 3, and so on. Okay, you cannot find any real number whose square is negative. Okay, so no R, no real number such that above equations are satisfied. Okay, you cannot find any real number whose square is negative. Okay, so now what to do? Here R is expanded. Okay, R is expanded to include, not include in itself, the set is expanded to include what you know as, what you mean as complex numbers. Okay, these are complex numbers. Okay, fine. So negative square root, those things, complex numbers. So it has two parts, real and imaginary. Complex numbers are written in form of a plus iota b, and a is known as the real part. Okay, and this b is known as imaginary part. Okay, this is an imaginary part of the complex numbers. Iota is the negative of minus 1, square root of negative 1. Okay, so this is the theory behind why actually we are studying complex numbers. Okay, so we started by natural numbers, we went to integers, we went to rational numbers, then irrational numbers, then real numbers, and then to complex numbers. Okay.